Hello everyone. So we're going to go ahead and go over the next section, section 3.5, which is all about symmetry. So I would say out of all of the transformations that you learned about, reflections, rotations, and translations, this is probably the easiest one. And really this one is especially easy if you can just use your imagination. So essentially you just have to know that there are three types of symmetry. The first one is line symmetry, and we'll just kind of read what it says here. It says line symmetry is if a figure has line symmetry, if the figure can be mapped onto itself by a reflection in the line. Think of a mirror image. So really, ultimately, you can almost think like if you can get this figure and fold it in any way, like for example, if I got this, and I'm probably going to ruin my paper, but if I folded it over and I folded it across this line right here, notice, just use your imagination. If I folded this corner into that corner, then it'll almost kind of fold onto itself. So that's what we consider to be line symmetry. And that's true like if you had line symmetry this way or that way. It can be any line that you draw, as long as there's a one line that you can draw into the figure where it'll fold onto itself. And I like what they say here about thinking of a mirror image. This is almost like, it's almost like if this was looking into a mirror over here, then that's what will come up. All right. The next type of symmetry is point symmetry. So point symmetry, you just pretty much have to think. So it says it right here. A figure has point symmetry if the figure is mapped onto itself by rotating the figure about a center point. All right. So think about this right here. If I put a center point right here and I rotated this 180 degrees. In other words, basically getting the same figure that we had before and rotating it to where it's upside down. If it looks exactly the same as what it did before, see, it looks like a normal N, but if I rotated it 180 degrees, it looks like that same N again. That's what we call point symmetry. All right. So the best way is the best way of thinking about it is that the figure looks the same if you rotate it upside down. And then last but not least, we have rotational symmetry. This is essentially where, you know how with this one, it'll look the same if we rotate it 180 degrees. This one is pretty much saying if you rotate it really by more than just 80 degrees. So a figure has rotational symmetry if the figure is mapped onto itself by rotating the figure less than 360 degrees. So notice over here, if I get this point and I rotate it a little bit, well, it'll look exactly the same as before. No matter, as long as I rotated less than 360 degrees and there's several times where it looks exactly the same as what it originally did, then that's what we go ahead and consider rotational symmetry. So these problems and even your problem set is going to be extremely easy. That's why I gave you like 20 of them. All right. So what I'll probably do is just the first 4. And then at some point, I'm going to have you pause the video. I want you to try these on your own and then compare with mine as soon as I get through the video. So let's look at this. And the one thing you'll notice is that some figures have all of them. Some figures have some of them. Some of them only have one type of symmetry. So if you look at this one, does this one have line symmetry? Well, yeah, if you think about it, if I draw a line right here, that'll fold onto itself. I mean, I could draw a line right there. That'll all like... This side will also fold onto itself there, even through like the corners, right? The figure will fold onto itself. So it definitely has line symmetry. Well, let's think about point symmetry. If I got this figured and I rotated it upside down, it does look exactly the same as what it did before, right? So I'm going to go ahead and say that this also has point symmetry. Rotational, well, if I grab that and I rotate it, even just a little bit like that, it'll look exactly like it did before. And if I kept doing that a few more times, that'll still be the case. So it definitely has rotational symmetry. You'll also see that some of them have none of them. But you'll see a couple examples like that in a second. All right, so let's check this one out. Does this one have line symmetry? Yep. If I drew a line right down the middle, it'll definitely fold onto itself. And as long as you have one example of that, then that's enough justification for line symmetry. Now, does this have point symmetry? Well, let's see. If I put it 180 degrees, nope, it does not look exactly the same as it did before. So it does not have point symmetry. Does it have rotational symmetry? Well, let's see. Yeah, it does. Not necessarily 180 degrees, but less than 360, it will eventually look like itself, and it happens like that 2 other times. So it definitely has rotational symmetry. So as you can see, there are examples that have more than one type of symmetry and not others, and some of them are only going to have like one. So let's look at this one. Does this one have line symmetry? Well, let's see. there's really no, if I draw a line like that, nope, that'll not fold onto itself perfectly. Even if I drew a diagonal, nope, it wouldn't fold onto itself. So it definitely doesn't have line symmetry. Does it have point symmetry? Well, if I rotated it 180 degrees, does it look like it did before? I would say it does. So it definitely has point symmetry. And as far as rotational symmetry, well, let's see. Yeah, because here's the thing. If it has point symmetry, it automatically has rotational symmetry. Rotational is just saying that if you can rotate it less than 360 degrees and it looks exactly the same, then it'll go ahead and work. And if you notice, well, 180 degrees that works for point symmetry is less than 360. So if you have a check mark for point symmetry, then you should automatically put a check mark for rotational symmetry. Okay, and then let's look at this triangle right here. So let's see, is there line symmetry anywhere? Trying to think. I don't think there's any line that I can draw through this to where it'll fold onto itself. So it definitely doesn't have line symmetry. Does it have point symmetry? If I rotated this 180 degrees, it does not look like it originally did. So no point symmetry. All right, let's see if it has rotational. If I rotated this at any point, will it look exactly like it did originally unless I get back to less than 360 degrees? Not necessarily. So this is one of those cases where you have none. All right. So I think it would be a bit ridiculous if I went through every single example through this video. So what I would like for you guys to do is pause the video. All right. I mean, I can't tell you what to do, but that's my recommendation, is that you pause the video and you actually try out these problems and even the ones on the back on your own. This shouldn't, if it's anything like my students last year, they got through this whole thing in like 5 minutes. So, and just try to see for yourself. So I'm going to go ahead. All right. I'll give you a second to pause. All right, so hopefully you paused, and now here are the answers. I'll leave it there for like 5 seconds. All right, and I'll switch it to the back, and I think if I zoom out, you should be able to see the whole sheet. So hopefully you'll be able to see the answers from that. All right, so yeah, just go ahead and pause the video, and if you want to see this again or take a longer look at the answers, but I'm just going to go ahead and leave it at that, and hopefully this was helpful. And if you have any questions, you can always ask us if you have any questions.